Okay, so in these experiments we were testing for different ions that were in a solution. The very first one was to test if there was a chloride ion present in the solution. So in the first experiment, you added some chlorine salt into a test tube. To that then, you added some water, deionized water, and you added some silver nitrate into the solution. So the silver ions in the silver nitrate reacted with the salt and bonded together to form silver chloride. Now we saw that as a precipitate within the solution. So the observation was a white precipitate is formed due to the silver chloride. The silver chloride then is soluble in ammonia, and that's known from previous experiments and research done around silver chloride. So if we want to test that it's definitely silver chloride, that chloride ion is present, we're going to add in some ammonia into the solution, which you did in the experiment. Okay, and then when we did that, the white precipitate disappeared when the ammonia was added. So that confirms that it is actually silver chloride because it was soluble within the ammonia. So the conclusion is that the silver nitrate formed a salt of silver chloride, and that it was confirmed by the fact that it was soluble in ammonia, which confirmed the presence of the chlorine ions in the solution. Otherwise, it would not have been soluble. If there was no chlorine ions and there wasn't silver chloride, it wouldn't have been soluble in the ammonia. So that's the first one. The second one then is the test for the sulfate and sulfite ions. So we had our sulfate and sulfite solutions in two separate test tubes. We added barium chloride to both of them, and a white precipitate was formed in both test tubes. So the conclusion there was the white precipitate was barium sulfate and barium sulfite. So the fact that the white precipitate was there, that confirms that there are sulfate and sulfite ions in both of them. But now we need to distinguish between which one's the sulfate ion and which one is the sulfite ion. To do that, we added in some hydrochloric acid. When we added in the hydrochloric acid, we saw that one of the precipitates disappeared. So it reacted with the HCl and dissolved into the solution. The one test tube that did that contained the barium sulfite. And the reason is, due to the basic nature of the sulfite ion, the sulfite precipitate dissolved and reacted with the addition of HCl, which is an acid. So the acid and base reacted together, whereas the sulfate ion didn't react, so there was no reaction there, and it did not actually dissolve or was not soluble within the water. Okay, then on to the next one, which is the carbonate and hydrogen carbonate ions. Okay, so we added acid to both test tubes. That created a reaction for both test tubes, and we produced fizzing noises, and it looked like it was bubbling up, so a gas was produced. We tested that gas in lime water, and it was found that it was carbon dioxide for both of them. So that we know that there's some type of carbonate ion in both test tubes because the lime water turned milky. Now when magnesium sulfate was added, a white precipitate was formed in only one of the test tubes. So the conclusion is, when magnesium sulfate is added to a solution containing a carbonate ion, magnesium carbonate is formed, which is white and insoluble in the water. So it's going to create this white precipitate. the carbonate ion was detected in that test tube. When the magnesium sulfate was added to the other test tube, magnesium hydrogen carbonate was formed, and that's actually soluble in water. So we were able to distinguish between the two carbonate ions there. Okay, so we're on to the nitrate ion test. This is the brown ring test. So when we added in all of our chemicals, we saw that a brown ring was formed nearly halfway down the test tube, and we added in our sulfuric acid and our nitrate ion solution. So when the nitrate ion is oxidized to a certain amount, it turns brown. The solutions, the reagents that were gone into that test tube, allowed the nitrate ion to become oxidized. So that's why we saw that brown ring. So the nitrate ion is present in the solution. The brown ring is formed due to the nitrate ion being oxidized. Okay, it's like it's turning to rust. You know, iron, if it's oxidized, it turns to a different color. This is the same situation. So the nitrate ion was oxidized and it turned brown. So because of that brown color, we're able to work backwards and see that it's a nitrate ion. The last one was the phosphate. Okay, so we added in our chemicals and we saw that a yellow precipitate was formed this time on the addition of our ammonium molybdate, and the reaction between the aqueous ammonium molybdate to a phosphate ion solution produced the yellow precipitate. That yellow precipitate is very characteristic of our ammonium phosphomolybdate. So we can see there that that yellow color shows us that there's a phosphorus, that phosphate there. There's a phosphorus ion within the test tube. And that's it for those few experiments.